Hello everyone and welcome to the lecture on AWS Proton. So this lecture will contain all those topics. What is AWS Proton? AWS Proton for platform teams, AWS Proton for developers, AWS Proton workflow, AWS Proton terminology, how AWS Proton provisions infrastructure, and how AWS Proton works. So what is AWS Proton? AWS Proton is an automated infrastructure as code platform. AWS Proton automates the provisioning and deployment of infrastructure as code, streamlining application deployment process. It's a dual user framework, so it is meant for both admins and developers. So it functions as a two-pronged automation framework serving both administrators who create templates and developers who use the service or who use these particular templates. So you can manage serverless and container applications. So AWS Proton is specifically designed to handle both serverless as well as container-based application efficiently. So you have version service templates. So AWS Proton provides something called as version templates that define standardized infrastructure and deployment tooling. Standardized infrastructure deployment and AWS Proton ensures consistent infrastructure deployment across all applications. You have automatic version tracking. AWS Proton identifies all existing service instances using outdated template versions. So you have one-click upgrades. Administrators can upgrade outdated service instances with a single click. Self-service interface. Developers can select from available service templates through an intuitive self-service interface. Integrated CI/CD pipeline, continuous integration, continuous deployment pipeline. So you can automatically configure and integrate CI/CD pipeline for code deployments. Automated resource provisioning. You can automatically provision the required resources based on the selected templates. Versioned infrastructure templates. So platform teams. So think of platform teams as basically infra teams in the company or the platform team who manage the whole platform. And these platform teams can create and manage versioned infrastructure as code template. So you have versioned infrastructure that you can roll out and roll back, upgrade, downgrade, all those features are available. Standard application stacks. So you can define and maintain standardized application stacks across the organization using this particular service. And resource management. You can control and manage infrastructure resources effectively. Deployment pipeline control. So you define and standardize CI/CD software deployment pipelines. And it also helps with consistent architecture. So you can maintain consistent architecture patterns across all deployments. So first I will talk about how it helps the platform teams or the infra team. So platform team structure. So platform team consists of usually administrators and team members who work together to manage AWS Proton resources and configurations effectively. So basically you have template categories. AWS template uses two primary template types. Environment template for managing shared infrastructure across multiple applications, and service templates that define infrastructure needed for individual applications or microservices. So you would have seen mostly in enterprises and the companies, there's something like core infrastructure or the shared infrastructure which is shared across all the teams. And teams have their own individual applications or services which they want to manage. So you have two types. One is environment templates and one is service templates. Service implementation. An AWS Proton service represent an instantiation of a service template, combining multiple service instances with an integrated pipeline for comprehensive application management. And you have instance deployment. So AWS Proton service instances. So basically we are talking about team specific. So service instances, AWS Proton service instances are specific implementation of service templates within designated environments, which allows for consistent deployment across different infrastructure contexts. Then you have template relationships. So platform teams can define compatibility relationships between environment, which is the core, and the service templates. And that ensures that applications are deployed only in compatible infrastructure environments. Next is AWS Proton for developers, how it helps the developers. So as an application developer, you select a standardized service template that AWS Proton uses to create a service that deploys and manages your application in a service instance. An AWS Proton service is an instantiation of a service template which normally includes several service instances and a pipeline. So this is how the AWS Proton workflow looks like. So first, as an administrator, you create and register an environment template with AWS Proton, which defines the shared resources. AWS Proton deploys one or more environments based on an environment template. As an administrator, you create and register a service template with AWS Proton, which defines the related infrastructure, monitoring, and a CI/CD resources as well as compatible environment templates. As a developer, you select a registered service template and provide a link to a source code repository. AWS Proton provisions the service with a CI/CD pipeline for your service instances. AWS Proton provisions and manages the service and the service instances that are running the source code as was defined in the service template. A service instance is an instantiation of the selected service template in an environment for a single stage of a pipeline. For example, it could be prod. So let's go through some AWS Proton terminology so that will make it more clearer. So we have environment template, which is a collection of environment template versions that can be used to create AWS Proton environments. And we have environment template version, a specific version of an environment template. It takes a template bundle as input, either from a S3 bucket or from a Git repository. The bundle specifies infrastructure as code, IAC, and related input parameters for AWS Proton environment. Then environment, the set of shared AWS infrastructure resources and access policies that AWS Proton services are deployed into. AWS resources are provisioned by using an environment template version invoked with specific parameter values. Access policies are provided in a service role. Then we have service template, which is a collection of service template versions that can be used to create AWS Proton services. We have service template version, a specific version of a service template. It takes a template bundle as input, either from a S3 bucket or from a Git repository. The bundle specifies infrastructure as code, IAC, and related input parameters for a AWS Proton service. A service template version also specifies these constraints on the service instances based on the version. Compatible environment templates instances can only run in environments based on these compatible environment templates and supported component sources, the types of components that developers can associate with instances. Then a service, which is a collection of service instances that run an application using resources specified in a service template, and optionally a CI/CD pipeline that deploys the application code into these instances. Then we have a service instance, the set of AWS infrastructure resources that run an application in a specific AWS Proton environment. AWS resources are provisioned by using a service template version invoked with specific parameter values. Then we have a pipeline, which is an optional CI/CD pipeline that deploys an application into the instances of a service with access policies to provision this pipeline. Access policies are provided in a service role. A service does not always have an associated AWS Proton pipeline. You can choose to manage your app code deployments outside of AWS Proton. And finally, we have a component, a developer-defined extension to a service instance, specifies additional AWS infrastructure resources that a particular application might need. In addition to the resources provided by the environment and the service instances, platform teams control the infrastructure that a component can provision by attaching a component role to the environment. So how AWS Proton provisions the infrastructure? So there are three choices. First one is AWS Managed Provisioning. AWS Proton calls the provisioning engine on your behalf. This method supports only AWS CloudFormation template bundles. So under the hood, this AWS Managed Provisioning will take care of CloudFormation. So you can think of AWS Proton as a service, a higher level service built on CloudFormation. So when you work with CloudFormation, you have to build all those CloudFormation templates, the JSON or the YAML, and deploy them using stacks and all. But here, this is a higher level abstraction. So under the hood, it will call the CloudFormation for you. And basically, you will just put in some values in the forms and all, and it will trigger a CloudFormation template for you. Then second option is code build provisioning. AWS Proton uses AWS code build to run shell commands that you provide. Your commands can read inputs that AWS Proton provides and are responsible for provisioning or deprovisioning infrastructure and generating output values. Our template bundle for this method includes your commands in a manifest file and any programs, scripts, or other values that these commands may need. As an example, to use code build provisioning, you can include code that uses the AWS Cloud Development Kit, AWS CDK, to provision AWS resources, and a manifest that installs the CDK and runs your CDK code. So this is the second way. And then you have third option, which is self-managed provisioning. AWS Proton issues a pull request PR to a Git repository that you provide, where your own infrastructure deployment system runs the provisioning process. This method supports only Terraform template bundles. So under the hood, you can use Terraform for this. So you can choose from any of these three options. So now this is a bit of repetition, but just to make it very clear how this is basically the terminology and workflow. So this is just going a bit deeper. So how this works step by step. So when you as an administrator select an environment template with AWS Proton, you provide values for the required input parameters. AWS Proton uses the environment template and parameter values to provision your environment. When you as a developer or administrator selects a service template with AWS Proton, you provide values for the required input parameters. You also select an environment to deploy your application or service to. AWS Proton uses the service template and both your service and selected environment parameter values to provision your service. You provide values for the input parameters to customize your template for reuse and multiple use cases, applications, or services. To make this work, you create environment or service template bundles and upload them to a registered environment or service templates respectively. Template bundles contain everything AWS Proton needs to provision environments or services. When you create an environment or service template, you upload a template bundle that contains the parameterized infrastructure as code IAC files that AWS Proton uses to provision environments or services. When you select an environment or service template to create or update an environment or service, you provide values for the template bundle IAC file parameters. And that's all. Thanks for watching.